Okay. So we'll just continue on where we left off in chapter 6. This will just be a relatively quick part of the chapter here. Just reviewing what we've done with mean and median. If you were going to find the mean of everything here, what would you have to do?
Add them all up. And divide by the number.
So add them all up. Divide by the number that you have. So in this case, 6 salaries. What number do we get?
$178,833.33.
Okay. So mean of about $178,000. That would be a super nice salary. That's for sure. What about the median?
Median, where we put them all in order.
Yep, so we got to put all these in order. Like that. And then we start crossing off extremes. So 54 can go, 750 can go, 60,000 can go away, 74,000 can go away. We're left with 2.
Add them up, by
So then the median will be
67,500.
67,500. Okay. So 67,500. Any questions on how to calculate either of those? Okay. From there, we're going to be talking about distributions. Typically, what the graphs look like, what does it look like to be normal, left skewed, right skewed, that sort of thing there. Number of peaks is always something that you'll want to keep in mind. If there's one peak, it's called a unimodal distribution. Uni prefix of 1, so one mode is what it's saying. Bimodal means 2 peaks or 2 modes, such as that picture there. Some other shapes that you could have here. If it has an even look to it where the peak is near the center and everything else goes down from there, it's symmetric. But if you have a case where you have a lot of really big values and a long tail going that way, that would be left skewed, because the tail is going to the left here, right? This one over here, a lot of low values. Tail is going this way toward the right, so this will be right skewed. Depending on what type of situation you have, will determine which of these 3 situations you'll have. with the data. So keep in mind, if it's symmetric, the mean and the median are both located in the center. If you have this first kind of shape, mean and the median would both fall in here somewhere. If it's left skewed, the mean will fall to the left of the median. So in other words, median is probably going to be around here somewhere.
I want to be in the middle,
Why wouldn't it be in the middle?
because I can think that
I can answer this. We're talking about like the bottom two, right?
Yeah.
Because the taller ones have more. Right?
And the median, you're going to be 50% of the way through the list, right? So for example, if I just put some numbers
So
in
it takes
here.
more of this side to get to 50% than it does to the taller side because there's more.
Yeah. Yep. So median might be somewhere around here, but the mean might be somewhere over here, just because you have a lot of low values that are going to bring these upper ones down. And then if it's right skewed, the mean will be above the median. So for right skewed, median might be right here somewhere, and the mean will be toward the right this way. We can often guess the shape of a particular variable based on the situation at hand. But this leads to variation. Key here is how spread out the data is from the center.
How it goes, do not make sense. Why is the low one high and the high one low?
Variation. Did not love my.
Mhm. Yep, so it's going to be measuring this distance. So a lot of values are really close together. And that one, this one, they're going to be more spread out than they were in the first one. And then the last one here, they're really spread out. So basically, the more horizontal distance you have there, the more variation there's going to be on the graph. So everything so far, mean, median, mode, range, those are all measures of center. Things that are going to tell you where the center of the data is. There's also measures of variation. And that's where we're going to need something else here. So if you compute the mean and median of each of these, what would the mean of data set 1 be?
Fifty.
50. Yep. What about the median?
50.
Also 50 for 1. What about for the second set? Yep, they're all in order.
50.
50. Median of that.
50.
All 50. What's that? I thought I heard something.
Oh, yeah, I said, what's next?
Kind of interesting, huh?
Given that they're all like having a 1, 2, 3, 4, 5. There's 6 numbers in the bottom one, and like 5 numbers in the top one,
Mm-hmm.
and they're all different numbers. And but like, I'm trying to add like I feel like there's more of a value to the bottom one than there is
For the top one.
in the top one.
Okay. So the question here, because it's kind of strange that they all were 50, which one are the numbers more spread out? The first one. So we're going to talk about something here in a second called standard deviation. So standard deviation of 1 is going to be higher than standard deviation of 2. And that's because the numbers in the first set are more spread out than they are in the second set. But the idea is that standard deviation is going to be the thing we can do to measure how far apart values are in a set of data. Measures of variability, standard deviation. Range would be considered variability as well. Range would be considered variability. The higher the range, the more spread out numbers could be. There's more of a range of numbers that could fall in between the lowest and the highest, which allows them to be spread out more.
So you would just take like each number that's in the data set, you would take it as if the mean is 50, you would take it
Mhm.
minus 50,
Mhm.
and then square it,
Mhm.
and then the number of all of them minus 1, and then divide that, and then
And then take the square root.
square root. That is, I was gonna say square it again, but I knew I was wrong.
Mhm.
Square root.
That's essentially the process here for calculating standard deviation.
And we have to do that.
Mhm. Yep. But we can do that. So the process that you just described there, always find the mean first. What you're going to do is take each data value and subtract the mean from it to get the deviation from the mean, or how far away it is from the mean. Once you do that, then square all of those. Then we're going to add up all of those values. Divide that by the total number of data values minus 1, and take the square root of what we got in that step there. So the example, if you have the numbers 21, 25, 20, 15, 18, and 21, let's find the standard deviation. So the first step is to find the what? Mean. So step one, find the mean, which in this case is going to be adding all of those up, divided by, what's that? It's 20. Dividing that by 6 gives you 20. Next step is find the distance from the mean for each data value.
So you have 5, 2.
So like 21 is the first value.
Oh, you have to go in order?
It doesn't really matter, but
I was going from this year, like from like lowest.
lowest to
from 15,
highest.
18, yeah.
You can do that. So if we do that, 15 minus the 20 would give you a distance of
5. Oh, wait, hold on. We're doing
-5, right? Yep, the next one would be the 18 minus 20, so -2. Then 20 minus 20, 0.
We have 2 21s, we would go to 1,
Mhm.
and then 25 minus 5.
Mhm.
So then you would,
So then you have to square each of the numbers that we got from step 2. So in other words, those numbers and those numbers. So -5 squared would be -25. From there, -2 squared, 4. 0 squared would be 0.
and 1, and 1.
1 squared for 2 of them,
And then 25 again.
and then 25 again. Make sure that whenever you square a negative number that your result is positive, because negative times a negative is a positive. So if you are doing any of these and you get negative numbers, that's going to be a mistake there. So then from there, step 4 was to do what?
You have to add them all up and subtract by 1.
So add all of the numbers together, which would give us what number in this case?
56.
56. Then from there, we will divide this number by the number of data values minus 1. Yep, so 56 divided by 5 then. 11.2. 56 divided by 5.
But I thought 56 had to be squared. We already squared all that.
Because we already squared the values
So
and
now could we just add them all up and then square the final number? But that probably wouldn't work,
yep, that would lead to a different answer.
right?
But say we were to do that. So you were saying like add up -5, -2, 0, 1, 1, and 5, right?
Yeah.
So if you added those up, that would be -7 plus 2. That would actually be 0.
Oh, so yeah, that really wouldn't work.
And then squaring that would still be 0. And then the last step after doing all that,
Square root.
take the square root. So square root of 11.2 would give you about what in the calculator? 3.35.
Right.
And that will be the standard deviation for those numbers there, that set of numbers. And that 3.35 is giving you a measure of how far away the numbers are from each other in that data set. The higher this number is, the more spread out the values are. The smaller that number is, the closer together they are. Any questions on how to do this process? So if you need to see the worked out solution here, mean first, with each value, find the distance away from the mean, square the values, add them up, divide by number of values minus 1, and then take the square root of it. So if nothing more, our work matches the solution here. And that is always a good thing. Now you can do this in Excel as well. For mean, median, mode, there are functions that you can use. Usually equals average, parentheses, equals median, parentheses, equals mode, parentheses for the first 3. Standard deviation is going to be equals stdev.s. The only thing to keep in mind when you go into Excel, you might also see this function as well. What's the difference? P. What do you think S and P stand for? Sample and population. So kind of applying some of the chapter 5 things there. Sample for S, population for P. Just so you know, there is a slightly different way to calculate population. What's the difference?
Don't look at me.
Don't know. It will follow exactly the same process except one change. I'm just going to highlight where that is.
Do you add one instead of subtracting one? Or do you just not add any, or subtract anything?
Yep, so we won't subtract anything for population.
I'm sure. What does the one do? Why is that?
Why is it there?
Yeah, which one is it gonna do? One number?
The reason for that, whenever you pick a sample from a population, depending on where your endpoint is in the sample, it might be the same place where the population starts or ends, or it might not be. So to account for that difference, they have the -1 in there. So essentially, if you have, say this is the population,
Okay,
and you pick a sample of, say, those three there,
okay.
the 21 is at the end of the population, right?
Right.
The thing that gets interesting with standard deviation calculations, depending on your set, the endpoint may or may not be included.
Oh, okay.
So just to make sure that we account for the situations where it isn't, then we have the -1.
Ah,
Okay. But yeah, and then whenever it's the population, it's just looking at everything, whether or not it's included or not.
instead of just saying, right?
Yeah. Yep. I think for our purposes, though, you'll only ever have to calculate sample on like an exam. But any questions about anything there? Okay, there is a way to interpret standard deviation. Dude by the name of Chebyshev has a theorem there. At least 75% of data values will fall within 2 standard deviations of the mean. And at least 89% of all data values will fall within 3 standard deviations of the mean. Did all of this last year?
It was,
That's okay.
yes, I did all of this last year.
Okay. Okay.
I have to go back and see if so told you I hated the teacher, so I like burnt, I think I burnt the folder, but I hope I still have some stuff left.
Okay. Well, I'll be honest, because it was a stats course, right? This is pretty much all the further we will be going in stats. Unless you want to include probability, because that will be
No.
chapter 7. So we will have that.
That's okay. Yeah, I did that too.
Okay.
My last not probably.
That's okay.
I did not use that.
I haven't done algebra. It's great.
So I'll explain to you what Chebyshev's theorem does here through an example. So the delivery service collected data on the number of deliveries made per week by their 500 drivers. The mean of the data was 250 deliveries with a standard deviation of 10 deliveries. So we know 75% of drivers must fall within how many standard deviations of the mean, according to his theorem? 2, right? So if one standard deviation, which by the way, standard deviation is often that symbol there,
What's that called?
sigma,
Sigma, that's it.
hmm lowercase sigma,
It's there's
one of the Greek letters.
What about the other one? Mu?
Yep, mu, that would be the U with a tail on it. Although uppercase sigma, I'm willing to bet you've seen this one. That one just means sum or add everything up. And the other one that you know that you probably don't think about too often, I'm sure you know the lowercase one,
Pi.
pi. So you use lowercase pi all the time, but there's an uppercase pi. It actually means product. So multiplying things together, if you ever needed that. So with that in mind, one standard deviation is 10. So that means two standard deviations would be 20. So then think to yourself, that many above and that many below the mean is where we can be.
So between 240 and 260.
So between 240 and 260 would be within one standard deviation of the mean.
No more than 22.
Yeah.
So is the 20 above or below?
It could be either one. So if you were 20 above, you would be at 270.
Oh, I went by 10. So we have to do both because 20 is by 2. So it would have to be 230 to 270.
Yeah.
So the mean, it says, the mean through data.
Yep. So mean was 250.
So the Sherry Sharp's, whatever it is, theorem is that it can go go by 2. Wrong. So if, like 2 standard deviations. Okay, so it says 250 deliveries with a standard deviation of 10. So if one standard deviation is 10, but if the theorem can go by 2, you have to go by 20. Okay, so that's where you get the 20. So then you would subtract off of 250, coming off of 250, and then add 20 on 250. That way you can get your
Full
lowest
range.
and your highest.
Mhm.
Big one.
Okay. And then 89% of drivers, Chevy says 89% would need to be how many standard deviations? 3. That's from,
Okay. Now, I didn't write that down.
Yeah.
Is that like,
For everything?
yep, everything dealing with Chevy Chev. So if it says 75%, that's going to mean
yes,
2 standard deviations.
yeah, if you see anything 75%.
Or if you see 89%, that's going to be 3.
So,
And that applies for every.
Yep, according to his theorem. Yep.
But it will tell you in the question if you're using the change notes. There or not.
I understand.
Either that, or if it gives you one of those two numbers there, like 75 or 89%, that'll be a cue to use his theorem there. Although, fun fact, do you know where Chebyshev is from? Any guesses based on the name? Pennsylvania?
German.
You're in the right part of the world.
Okay.
Czechoslovakia.
Getting closer. Okay, closer.
I don't, I don't know any really
Think a giant country next to those.
China.
I'm from Hong
Okay.
What?
Kong. Me person.
With,
What other country?
like, when you look at a world map, the biggest one on the map is
China.
one other,
Russia?
Russia. Chebyshev is Russian there. Not that you'll need to know that, but just a fun fact for you.
So why do they, is that why it's like the weird name? Like, are there all my names like that?
That's just his specifically, but depending on who came up with it is who they get named here. But for example, in the calculus class that I teach, one of the theorems that we deal with is named after a guy named Taylor. He was from England.
But Taylor's
So-
not a weird name.
Not really, no. I'm trying to think of some other ones, like Pythagorean theorem. Yep, Pythagoras. That was named after someone in ancient Greece. Is who that was named after. Let's see, Riemann. That's another calculus one. He's German. But all kinds of, you probably have. Or if you use the distance formula of any kind, that's basically that. But anyway,
I'm sorry, that was so funny.
89% of drivers would need to fall within how many standard deviations? 3. So 3 standard deviations would be how many deliveries?
30.
30.
Well, the low, like, minus.
Yep, so 30 away from the mean in either direction.
So 220 and 280.
Yep, 220 and then 280. So then the idea, would you be surprised if a driver reported making 400 deliveries?
Yes.
Yes. Significantly away from where it would be expected to be. Okay. Any questions on how to work with standard deviation or Chebyshev or mean, median, mode, any of those things? Let me see if I got any questions from home. It doesn't look like it. So we can do a couple of things here. Let me just go to the calendar. So just looking at the calendar coming up here. So some homework's due tonight. We'll have our next in-class assignment on Thursday. We are having our next exam a week from today.
On this stuff.
Yeah,
Final on this class?
yes.
Oh, boy.
Mhm. Yeah, the final, depending on how quickly we finish, it'll either be Thursday, December 4th, or possibly the week after on Tuesday. I know the week after on like the week of the 8th, that's
Do we have, like,
technically supposed to be finals week.
do we have like a review kind of thing before we final?
Yeah.
Okay.
Yep. So what I can do, I do have the review here for exam 2, if you'd like to look at that. And I'll just kind of tell you my plan coming up for the next couple of weeks then. So exam Tuesday next week. We'll probably have the next in-class assignment 10 on Thursday.
Or in November, right?
Yeah, we're in November here. Tuesday, the 11th, I'm probably not going to be able to be in class that night. So I might post something for you for chapter 7, which is going to be the chapter on probability. So I can answer any questions you have on the 13th about that. Just because since you had probability before, is it something that took a lot of practice, would you say?
No, I don't think it was too bad. It's
Okay.
just like, it's a lot of repetitive.
Mm-hmm. And very situational too. So it might take some time to look at the different situations there. Probably will review for that exam, which is just on probability, chapter 7.
Oh, that's all.
Yeah, traditionally it was at least.
So it's probability hard or easy.
I think it honestly depends on the person. I can't say much because when I was in college myself, I was a math major, obviously, but I had to do a full course on just probability. So, but that's how complex it can get. So, but then after that, there's one more chapter right before Thanksgiving, which is going to be the math behind politics, like different ways of voting, followed by a short group project, but it'll just be the 3 of you in the group. Review for the final and then final exam. But that's essentially the plan coming up there.
So if we finish our final,
Mhm.
if we finish our final in one day,
Well, how that will work, the final is traditionally 2 hours. So we would just have to stay a little bit later on whatever night we take it.
even if we're done in less than 2 hours,
If you get done before the 2 hours,
because
Mhm.
technically our finals go through like December 12th.
Mhm.
So we're basically like, if we finish our final on the 4th or
Mhm.
whichever day, do we have to come in the next week?
Nope, once the final's all done and everything's submitted, then we'll be good.
Even if other people are still taking theirs, but we're finished.
Yeah.
So then typically, if we don't have English after. What if like,
I take it out here in 2 hours. Do I come in the next week?
It's one of those things where after 2 hours, I'll have to collect it.
I'm gonna finish?
Just because with everybody else in the course, that's how long they get. So,
Yeah, it would be fair. Right?
Your first time 5 years. I haven't objected.
and for those of you in the online section, it'll work just like how the other exams do. It'll open the week before it's due, and then you'll just have to complete it within the time period in one sitting with the lockdown browser.
I was gonna say, I'm like, wait, what? It opens a week before?
Well, they'll have a week to complete it, but
Right.
then they have to do it within the hour or the 2 hours, whatever it is.
Or all their exams time?
Yeah.
Well, that's good. I did one time online.
Yeah, it's timed, and then they have to use the lockdown browser where it records their screen and their like webcam and that kind of stuff. But since you guys are right here in front of me, we don't have to do that. So
And it was the final exam on.
yeah, and it is pretty much on the entire course. So yeah, but I'll give you the review for this exam coming up.
My like ancestors or something on. Don't like you.
And I do have the answers here, but I'll give you a little bit of time to look at it first before I hand you the answers.
Thank you.
You're welcome.
She's so confident.
Okay, and I'm just going to go through all that again for the online section since I'm sharing the screen. Okay, so pretty much will work the same way. Exam 2 just opened today for you in the online section. It'll be due by 11:59 p.m. Tuesday next week. Just make sure you complete it by then because it will lock at that time. We'll have some in-class assignments coming up. The third exam will open for you on November 13th. Will be due by 11:59 on the 20th. You'll have one additional project due the Thursday before finals week in December. And then for the online section, your final exam will be due probably December 8th on Monday by 11:59 p.m. But for the rest of class tonight, they're going to be looking at the Exam 2 review. Which can be found under modules for lesson 3 at the very end. These two files right here.